Alrighty guys, here we are, April 15th. This is actually our last lesson before you guys go and take your test next week. So from here on out, please make sure that if you have any questions, you get them answered so that you guys can be very successful on your test next week. Alright, so this lesson is called One Solution, No Solutions, or Infinite Solutions. So we're going to read through this. It says, Amy and Damon were solving an equation from their math homework. They came across the equation shown. So we have 3x plus 7 equals 5x plus 2, and then times the quantity 3 minus x plus 1. So examine each solution strategy. So this is how Amy solved it. She started off by subtracting the 5x on both sides. So if you look here, she subtracted 5x here, and she subtracted 5x. So once she did that, she was left with negative 2x plus 7, which would then be equal to 2 times the quantity 3 minus x, and then plus 1. From here, she distributed the 2 to both the 3 and the negative x. When she did that, she ended up on the left-hand side still having negative 2x plus 7 equaling, so 2 times 3 is 6, plus negative 2x plus 1. She decided that she was going to combine her like terms, so she added the 1 and the 6 together to get 7. And once everything was all said and done, she decided she had negative 2x plus 7 equals 7 plus negative 2x. She added 2x to both sides, and when she did that, she was left with 7 equals 7. And I would hope by now that we know 7 does equal 7. If I have 7 apples, that means I have 7 equals 7 apples. Now, if we take a look at Damon, he did something a little bit differently. What Damon did first was he actually distributed the 2 to both things inside the parentheses. Because again, remember, they're both working on the exact same equation here. They just did it 2 separate ways. By doing this, Damon then was able to combine his like terms right away. So he rearranged, all he did from step 2 to step 3 is he rearranged that right-hand side so his constants were together and his variables were together. Because he did that, he was able to simply combine 5x plus negative 2, or 5x minus 2, and then he was also able to combine 6 plus 1. Now, when he did that, he was left with 3x plus 7 equals 3x plus 7. So he subtracted the 7 on both sides, and when he did that, he was left with 3x equals 3x. He divided both sides by 3, and when he did that, he was left with x equals x. And surprisingly enough, if we look down to number 1, it asks to explain why both Amy and Damon's methods are correct, but have different solutions. So they actually are correct because both of them were equal to each other. And what I mean by that is if we look at Amy, her answer was 7 equals 7, which 7 equals 7. That's not like I'm going to say, oh, I have $7. That equals $14. No, $7 equals $7. Similarly, Damon had x equals x, right? If you're talking about xylophones, you can't say xylophones equals zebras because that doesn't make sense. X equals x. So for this situation, both methods are correct because the answer that they got are equivalent or equal to each other. What I want you to do is I want you to write why they are different. So what is the one thing that makes them different from each other? There was one thing and I've already pointed it out to you. Now number 2 says, how would you interpret the final equation in each solution? Is the final equation always true, sometimes true, or never true? And then explain your reasoning. So the final equation is actually always true. Why? Because 7 is always equal to 7, and x is always equal to x. And then number 3, this is true because we need to explain whether the equation has one solution, no solution, or an infinite number of solutions. And the answer here is an infinite number of solutions because no matter what number you were to plug into x, so let's say we wanted to plug in 762, well, if x equals x, 762 equals 762. And you can go the other way as well. No matter, so if you have 46, 46 is always equal to 46. So now your job is to consider another equation. So this equation is still solved by Amy and Damon. And this time, they got a little bit of a different answer. So I want you to take some time, observe this, and see why and how Amy and Damon got similar but different answers. And then go ahead and answer questions 5 and 6. So 5 and 6 are very similar to what we did in 1 and 2, but obviously it's going to be a different answer because when you're looking at it, I don't think those answers look the same. So go ahead. This is activity 2.3, and then the video for 2.4 is coming next.